Hey everyone, welcome back to the channel Code with AKJ. Today is day 21 of solving LeetCode 75 challenge series. So today we'll be tackling a fun and logical problem from the LeetCode 75 challenge, that is unique number of occurrences. So we'll start with a brute force approach and optimize it step by step. So let's get started. So the question says, given an array of integers ARR, return true if the number of occurrences of each value in the array is unique or false otherwise. So let's look at a few examples to clarify. So example 1, input array 1 2 2 1 1 3. So the value 1 occurs here 3 times, the value 2 occurs here 2 times, and the value 3 occurs 1 time. So we need to check the number of occurrences of each and every value. So since the occurrences of each and every value is distinct, so we can return true here, as no two values have the same number of occurrences. Same with example 2 here. So here the value 1 has one number of occurrence and value 2 has one number of occurrence. So here, since the number of occurrences of these two values are same, we need to return false here. Coming to the example 3, minus 3 has 3 occurrences, 0 has 2 occurrences, 1 has 4 occurrences, and 10 has 1 occurrence. So here each and every distinct value has distinct number of occurrences. So in this example, we'll return true. So now as we have understood the problem statement, so let's get started with our brute force approach. So here's the idea. We'll count the frequency of each and every number, and then we'll check if these frequencies are unique or not. So it's quite simple. So let's quickly write the output of these three examples I have written here. So in this given example 1, so 1 has 3 occurrences, 2 has 2 occurrences, and 3 has 1 occurrences. So the number of occurrences here are different, so we'll return true in this case. So here 1 has 1 occurrence and 2 has 1 occurrence. So since the number of occurrences are same, we'll return false in this given example. And in the third example, minus 3 has 3 occurrences, 0 has 2 occurrences, 1 has 4 occurrences, and 10 has 1 occurrences. So since we see the frequency of each and every value is different, so in this example we return true. So our brute force approach here would be to count the frequency of each number. We can use here map to count the frequency of each and every element, and we'll iterate over this map and we'll check the frequency of each and every value or the key. So every key has a value. So in our case, the key would be the distinct element and the value would be the frequency of this particular key. So we'll iterate over this map and we'll check the frequencies. So if the frequencies are same, we'll return false while breaking from the loop. And if we found the frequencies are distinct, so we'll return true in that case. So let's quickly write this code and let's submit. So let's quickly write the code. So initially we'll take the size of a array. We'll take unordered map to find the frequency of each and every element. We'll iterate over the array and we'll store the frequency of each and every element. So this would be our first step. The second step here would be to use a vector of frequencies where we'll use all the frequencies of each and every value. We'll iterate over our map and we'll push back the frequencies of each and every element or key values. So here the frequencies are stored in the form of x dot second. So in this way we have stored all the frequencies of each and every value in our frequency vector. And now finally, using two for loops, we'll iterate over this frequency vector and we'll check whether we have equal number of occurrences or not. So we'll use two for loops. One moves from 0 to frequency dot size and one moves from I plus 1 till frequency dot size. So if frequency I is equals to frequency of j, here it means we have found equal number of occurrences. So in this case we'll return false. And if after finishing our for loop we didn't found any such case where the frequencies are equal, we'll return true. So let's quickly run this code. So okay, so let's submit. As you can see, this approach gives a successful submission. So while this approach works but has a time complexity of O of n square, as we are using two for loops to find out if the frequencies are equal or not, and the space complexity here would be O of n, as well as we are using an external data structure here to store the frequencies as well as to count the number of frequencies. So let's quickly optimize it. In our optimal approach, we'll use the same map to count the number of frequencies of each and every element. Instead of using a nested loop here, we'll use a set to store the frequencies, and we'll check if any frequency repeats or not. So in this way, it reduces the time complexity and space complexity as well. So let's quickly see our optimal approach, how it works. So in our optimal approach, we'll use map here to store the frequencies of each and every element. So while using map, we'll get values as 1 to 3, 2 maps to 2, and 3 maps to 1. So while in our brute force approach, we have used nested loops to check whether the number of occurrences are equal or not. But in our optimal approach, to optimize that code, we'll use set here to store all the frequencies, and we'll check while inserting the values into our set whether it already exists in our set or not. So if it exists, we'll return false as we have already a number of occurrence there, and if not, we'll insert that inside our set. So after inserting all the frequencies, if we didn't find any equal number of frequencies while inserting it into the set, then we'll return true at the end of the code. So this would be our optimal approach where we have used both map and set. So the time complexity of this approach would be O of n, as we are using a single loop to count the frequencies and a single loop to check the equal number of occurrences. And space complexity here remains same, that is O of n. So in this way, we have reduced our time complexity from O of n square to O of n. So let's quickly write this code and let's submit. So let's quickly modify this code and use our set to check whether we have equal number of occurrences or not. So the initial code would be same here. Instead of using the vector to store the frequencies and use a nested loop to check whether we have equal number of occurrences or not, here we'll use set and we'll loop in our map, and while inserting the values into our set, we'll first check whether this set already contains this particular value or not. So if the value already exists in our set, we'll return false, and if not, we'll insert that value into our set, that is mp.second. So while inserting this particular value into our set, if we didn't found any already existed value, we'll get out of that loop and finally we'll return true. So let's quickly run this code. So okay, so let's submit. As you can see, this approach also gives us successful submission, but here the time complexity is O of n because we are just iterating through the array and the frequency map, and the space complexity is also optimized to O of n. So as we already tried on this optimal approach with this given example, let's quickly go back to our time complexity and space complexity analysis. Brute force approach takes O of n square time complexity and O of n space complexity, whereas in our optimal approach where we have used both map and set, the time complexity reduced to O of n and space complexity is O of n. So in this way, using set, we have optimized the time complexity from O of n square to O of n. And there you have it. We solved the problem using both brute force and optimal approaches. So if you enjoyed this video, give it a thumbs up, subscribe for more coding content, and don't forget to hit that notification bell. Comment below with your favorite optimization trick for coding problems. So I'll see you in the next video. Thank you.